What we're going to be taking a look at today is how to convert coordinates between polar and rectangular. All right. So if we have a polar coordinate, then we have a radius and theta. If we want to change that coordinate to something that's rectangular, then we need to figure out what x and y are going to be. So these are the equations that will give us x and y when we have information like r and theta. All right. And then on the other end, we have rectangular to polar. So if we're starting with a rectangular coordinate, we have x and y, and we're trying to find r and theta. So to find r, we would use this equation, which only uses x and y, and to find theta, we would do tangent inverse of y over x. So I'm going to go ahead and just show you where these formulas come from in another video. So if you are interested in learning more about that so that you don't have to memorize these formulas, you can check out that next video. So the first thing that we're going to do is we're going to convert the point 2 comma pi to rectangular coordinates. Now I know that this is a polar coordinate simply because there's an angle, right? Pi is a theta. If we had a rectangular coordinate, we would only have numbers like 2 comma 3 or 5 comma 0, whatever it might be. So we have to understand what we have and where we're going. So before we do the conversion with the equations, I want you to think a little bit intuitively about this. So we're going to go ahead and we're actually going to find the answer really quickly, but then I am going to show you the formula. We have this point 2 comma pi. Now if I graphed 2 comma pi, I would have a radius of 2, and I would go positive pi. I would be at this point right here. Now, if you think about what a point that's 2 units away from the pole or the origin on a rectangular graph, what coordinate would that point be? Well, if this were a bunch of boxes and I was 2 units away, the xy coordinate would just be negative 2 comma 0. And that's actually the answer to this problem. So there are some times where you can just basically visualize where the point is, and if it's on one of the axes, the x or the y axis, you can figure it out without using the conversions. But I'm going to go ahead and show you how to use the conversions so that you can turn any coordinate into a rectangular coordinate, because sometimes they're not going to be on the axis. Alright, so let's go ahead and see. If we want a rectangular coordinate, we need to figure out what x is, and we need to figure out what y is. So this tells me that I need r times cosine of theta. So I need my r, which is 2, cosine of theta, which is pi. Alright, if you want, you can use your calculator, you can use your unit circle. If you are going to use your calculator, make sure you are in radian mode. So I'm going to do 2 times cosine of pi. Again, you could just use your unit circle. We get negative 2, which we knew, right? Because we plotted the point before. For y, I'm going to do r times sine of theta. So 2 times sine of pi. So we already know what to expect, but let's go ahead and plug it in. 2 times sine of pi, we get 0. So the xy coordinate is negative 2 comma 0. Once again, we already knew that in the very beginning. Let's go ahead and do it the other way now. So we're going to do another example, and this time we're going to convert a rectangular coordinate into a polar coordinate. So we're going to convert the point negative 1 comma 1 to polar coordinates. Alright, so if we want a polar coordinate, we need r and we need theta. Alright, so for r, we're going to do x squared plus y squared all inside of the radical. So we have negative 1 squared plus positive 1 squared. Right, so negative 1 squared is 1, 1 squared is also 1, so 1 plus 1 is 2. We can't simplify that anymore. Alright, for theta, I'm going to do tangent inverse of y over x. So my y is 1, my x is -1. So I can go ahead and plug that in. I'm going to actually change my mode to degrees, because I don't want decimals in case I get a decimal, and I can convert it myself if I need to. So I'm going to do tangent inverse of 1 divided by -1, which is just -1. You can plug it in that way, and I get -45 degrees. All right, so we want to convert that into radians. So -45 degrees, right? We would do 360 minus 45. All right, so we have 315 degrees. So that would give us a 7 pi over 4. That would be the positive version, and we always want the positives. So once we have theta equals 7 pi over 4, we have to think about this a little bit, because if we take a look at a couple things, all students take calc, right? All students take calc. We know that we're dealing with a negative value, right? Because this 1 over -1 is -1. So if I want tangent inverse of a negative value, it can't be in quadrant 1 and it can't be in quadrant 2. So there are two places where tangent inverse of -1 gives us an angle. Now the calculator gave us the one that's in quadrant 4, right? 7 pi over 4. However, let's think about the problem that we're solving. This coordinate, -1, 1, is not in quadrant 4. It's in quadrant 2, -1, 1. So we need to figure out, well, what is the angle that's on this side? And it's really just a reflection, or it's 180 degrees away. So the angle that we're actually going to use is the one on the other side in quadrant 2. All right, so that again is 3 pi over 4. So the correct coordinate, polar coordinate for this problem is radical 2, comma, 3 pi over 4. So be especially careful when you're converting to polar, and remember that tangent can have a negative value in quadrants 2 and 4, and a positive value in quadrants 1 and 3. So keep that in mind when you're solving.